I was taught, and I don't know if this is still considered true, is that, spikes in blood sugar will trigger.
That suggests when you become active, you can actually regulate your appetite appropriately, or much more appropriately than if you're sedentary.
And do you think this has to do with changes in the brain centers that respond to satiety signals from the periphery?
A dietitian, talk to people like every week. It's like, this is great because you
for some, and then switch back. Is there any downside to doing that for sake of health or weight loss over time, or weight maintenance over time? Because I realize not everyone is trying to lose weight. And I definitely want to talk about at some point how to eat to maintain weight, because I think there are a significant fraction of people out there who are trying to do that. But yeah, is there anything, is there any downside to being a dabbler, keto for a few months and then omnivore for a few months, et cetera?
I think that's actually a great thing, especially to like maybe find what you feel is easiest for you, right? But in terms of like as a strategy, I mean, I guess, some people, this might get into dopamine, but like, change and get something new, and like, you feel a little bit more positive about it.
The new partner model.
Yeah, exactly. So I don't think it's how I would usually set things up initially for somebody. But if somebody said, hey, I just like to have some variety and change it up, as long as they're still like, their behaviors and they're doing portion control or whatever it is, and they're able to sustain a calorie deficit or, depending on whatever their goal is, I don't think there's really any downside to it. I do think the one thing to keep in mind is when you look at like going between extremes, so like low fat to low carb or vice versa, there can be in that transition period a little bit of weirdness, for lack of a better term. Like, for example, if you've been on a ketogenic diet and all of a sudden you move to like a higher carb diet, you'll be like basically insulin resistant for just a short period of time. Now, is that going to cause any health problems? Probably not in the long term, especially if you're still controlling calories. But just because your body has kind of like upregulated these systems dealing mostly with fat and glucose production rather than glucose metabolism. So now if you start taking glucose or carbohydrate back in, like for example, you give somebody an oral glucose tolerance test after they've been on keto, they'll do pretty terribly at it. But that doesn't last that long.
About how long?
A few weeks.
I think that's important for people to know, because I have a feeling during those first few weeks are the period of time when a lot of people will go running back to what they were doing previously, which is not to say that they shouldn't, but I've certainly done that. I've tried very low carbohydrate diet, and I would have assumed, and now I know I'm completely wrong, but I assumed that I was so carbohydrate starved for so long that my insulin sensitivity, which is a good thing, by the way, folks, would have gone through the roof, and I would be able to just sponge up every bit of glucose that I would have ingested through carbohydrate. So I did indeed switch over, and I felt like I had pretty terrible brain fog. I even got some jitters, and I thought, wait, what is this? My blood sugar was low before. Now my blood sugar should be in more moderate territory. But based on what you just said, I had upregulated the enzymes and systems in the body for fat metabolism on the keto diet, and then switching over, there was basically a ramping up of the molecules involved in presumably in glycolysis.
Transition period. I mean, think about like if you haven't weight trained before and you start weight training, you're going to feel pretty terrible, right? Like you're going to be sore and stiff and all that kind of stuff. But I will say you aren't necessarily wrong in what you said about being more insulin sensitive, because it depends on how you measure insulin sensitivity. So if you measure with something like, fasting blood glucose or fasting insulin or even HOMA-IR, those tend to be pretty good on low carb. But then if you do an oral glucose tolerance test, it tends to be pretty bad. And so it depends on your specific measure, right? So I think that, the idea that keto makes you, glucose intolerant or insulin resistant,
ouch.
I think, again, it's just a transition period, and I'm not too worried about it. But it is something important to keep in mind. And one of the reasons, like if somebody was to transition out of keto, typically if like I'm working with them or one of our coaches are working with them, we'll kind of instruct them to do it like slowly and kind of systematically over like a 4 to 8 week period. That way, hopefully, they're not having that period of 2 weeks where they're like, oh man, why do I feel so terrible?
Very important point. I want to go to the other end, literally and figuratively, and talk about gut health. Mm-hmm. Because up until now, and certainly—
I see what you did with that pun.
And certainly in the last few minutes, we've been talking a lot about sort of top-down processes, the brain, the psychology, placebo effects, but the very real aspects of those. For so long,
like for example, or whatever it is, and they're able. So I don't think it's how I would usually set things up initially for somebody, but if somebody said, hey, I just like to have some variety and change it up, as long as they're still like, their behaviors and they're doing portion control or whatever it is, and they're able to sustain a calorie deficit or, depending on whatever their goal is, I don't think there's really any downside to it. I do think the one thing to keep in mind is when you look at like going between extremes, so like low fat to low carb or vice versa, there can be in that transition period a little bit of weirdness, for lack of a better term. Like for example, if you've been on a ketogenic diet and all of a sudden you move to like a higher carb diet, you'll be like basically insulin resistant for just a short period of time. Now, is that going to cause any health problems? Probably not in the long term, especially if you're still controlling calories. But just because your body has kind of like upregulated these systems dealing mostly with fat and glucose production rather than glucose metabolism. So now if you start taking glucose or carbohydrate back in, like for example, you give somebody an oral glucose tolerance test after they've been on keto, they'll do pretty terribly at it. But that doesn't last that long.
About how long?
A few weeks.
I think that's important for people to know because I have a feeling during those first few weeks are the period of time when a lot of people go running back to what they were doing previously, which is not to say that they shouldn't, but I've certainly done that. I've tried very low carbohydrate diet, and I would have assumed, and now I know I'm completely wrong, but I assumed that I was so carbohydrate starved for so long that my insulin sensitivity, which is a good thing, by the way, folks, would have gone through the roof, and I would be able to just sponge up every bit of glucose that I would have ingested through carbohydrate. So I did indeed switch over, and I felt like I had pretty terrible brain fog. I even got some jitters, and I thought, wait, what is this? My blood sugar was low before. Now my blood sugar should be in more moderate territory. But based on what you just said, I had upregulated the enzymes and systems in the body for fat metabolism on the keto diet, and then switching over, there was basically a ramping up of the molecules involved in presumably in glycolysis.
Transition period. I mean, think about like if you haven't weight trained before and you start weight training, you're going to feel pretty terrible, right? Like you're going to be sore and stiff and all that kind of stuff. But I will say you aren't necessarily wrong in what you said about being more insulin sensitive because it depends on how you measure insulin sensitivity. So if you measure with something like, fasting blood glucose or fasting insulin or even HOMA-IR, those tend to be pretty good on low carb. But then if you do an oral glucose tolerance test, it tends to be pretty bad. And so it depends on your specific measure, right? So I think that, the idea that keto makes you, glucose intolerant or insulin resistant, I think, again, it's just a transition period, and I'm not too worried about it. But it is something important to keep in mind. And one of the reasons, like if somebody was to transition out of keto, typically if like I'm working with them or one of our coaches are working with them, we'll kind of instruct them to do it like slowly and kind of systematically over like a 4 to 8 week period. That way, hopefully, they're not having that period of 2 weeks where they're like, oh man, why do I feel so terrible?
Very important point. Go to the other end, literally and figuratively, and talk about gut health. Mm-hmm. Because up until now,
I see what you did with that pun.
And certainly in the last few minutes, we've been talking a lot about sort of top-down processes, the brain, the psychology, placebo effects, but the very real aspects of those. Not that I can imagine 2,000 calories is 1,000 calories and somehow change the law of thermodynamics. Can't do that. But we've been sort of top-down in integrating a lot of different ideas into weight loss, maintenance, and weight gain. But gut health, at least the more popular studies on gut health, have kind of blown a lot of things out of the water. For instance, this idea that you could take obese mice and literally give them fecal transplants from lean mice. And yes, that sounds like what it sounds like. Fecal transplants definitely inserted through the same end in which it comes out. And I point that out because a lot of people have asked me that they, and it was kind of scary to me. I thought, yes, this is not about ingesting feces. This is they literally do a transplant of feces from lean mice into obese mice, and the obese mice get lean. And yes, this has been done in humans, limited number of studies, and observed some pretty impressive effects on weight loss that I have to assume could be related to placebo effect. They might have told these obese people, hey, look, you're going to get lean through this fecal transplant from lean people. But more likely, it had some effect on their core physiology. I don't know which aspects, although I can speculate which ones. And they became leaner. They lost weight. And that is, in some sense, miraculous, when, especially given the important role of psychology and exercise.
Sorry.
Some effect on their core physiology. I don't know which aspects, although I can speculate which ones. And they became leaner. They lost weight. And that is, in some sense, miraculous, when, especially given the important role of psychology and exercise and satiety signals, because I'm going to assume that they controlled for a number of those other variables, although no study is perfect. What are your thoughts about gut health as it relates to metabolism, energy utilization, and balance?
Yeah, so the first thing I'll say is I'm not a gut health expert, but I feel relatively comfortable talking about it based on conversations I've had with people who are experts. One being Suzanne Devkota, who's are you familiar with her?
Well, she's sort of a phenom in this area, from what I understand.
So she was actually doing her master's when I was doing my PhD in Layman's lab. So she was one of my lab mates.
Terrific.
And the other thing to say is, even gut health experts, and Suzanne will tell you this, they're like, talk to me in 20 years. We just know so little. And I think that's an overall thing that people don't understand, is the scientific consensus moves very, very slow. And probably for good reason, because if we just flipped our scientific consensus based on one study, it would be a mess, right? So it's going to take time before we really understand the implications of the gut and what it means. So when it comes to weight loss, there probably is a role in there. I mean, we've seen that there's something going on. Now, whether is it something where a gut microbiome makeup that's more obese resistant, perhaps it extracts less calories out of the food you eat, right? Or perhaps it's elevating BMR, although I think that's probably somewhat unlikely.
Do you think it could impact the way satiety signals are?
So that's,
back to the brain again is the question.
We know that there's a link in the gut-brain axis. And so my suspicion is that it probably is working via appetite regulation. So that, if we look at the most effective obesity treatments out there, which is like semaglutide, you consistently see a 15% on average loss of body weight, which is massive, and people keep it off. That is a GLP-1 mimetic, which is a gut hormone, and it basically just is a very, very powerful appetite suppressant.
I guess I'm interrupting, but hopefully with a purpose.
Go ahead.
There's this really interesting study, and it's in mice, admittedly, but published in a neuroscience journal recently. And basically the takeaway is that, like so many things in neuroscience, the GLP-1 works in two parallel pathways. In the brain, it seems to impact neurons in the hypothalamus that control satiety, so exactly what you're saying. And in the gut, it seems to create an activation of the mechanosensors in the gut. Mm-hmm. So the perception is that the gut is full, mm-hmm. or fuller, I should say, not full, because I think people who take semaglutide don't feel bloated. I don't know, they might, but that one feels as if their gut is actually fuller because these mechanosensors that stretch are sending signals to the brain. Oh, like I actually have some food. I'm not empty down there.
Right.
Anyway, I'm tickled by this result, mostly because every time I hear about a drug or a molecule having effect, we think it has an effect at one location. Mm-hmm. But it's kind of interesting that, especially for something like appetite regulation, that it would be impacting body and brain in parallel. Anyway, forgive me.
That's okay.
You can tell I'm really excited about this. and here you are telling a neuroscientist, me, that a lot perhaps circles back to these brain mechanisms of satiety.
Yeah. I mean, I think that, and especially looking at the research on leptin, like we used to think, okay, metabolism is mostly like liver based, and then there's metabolism in the adipocyte and skeletal muscle, but none of this stuff exists in isolation. There's so much crosstalk between these pathways, and that's when we get into mechanisms. One of the things I love mechanisms, but one of the things I tell people is keep in mind that when you're dealing with an outcome, right? So like when I say outcome based, we're talking about physical outcomes like weight loss, fat loss, changes in blood markers, whatever. Though that is the summation of thousands of different mechanisms. So sure, sometimes you can affect a mechanistic pathway and you get kind of straight down the line outcome, but not always. Whenever you make a treatment or, kind of anything into the system, it's like throwing a pebble in a lake, right? It creates ripples. And we don't always know what those are going to be, right? And that's why, we've seen, certain drugs, well, it works on this pathway. And then they list off all the side effects. And you go, well, how would it create that many side effects? It's because nothing, for the most part, they don't just work in one place. There's a multitude of places it works. And to your point about semaglutide and the effects on mechanosensors, it's probably why a lot of people report actually kind of like low-grade nausea when they're using semaglutide because of that. Because if you're, that feeling is usually not like a real comfortable feeling, but it will get you to not eat. So I think there's absolutely likely a connection, but we haven't fully elucidated how that works. And when you think about how complicated the gut is, I think I heard something like there's more cells in our microbiome by far than there are in our body. So we're actually more, in terms of a cell per cell level, we're actually more bacteria than we are eukaryote, right?
There's Justin Sonnenberg, who's one of the world experts on microbiome. He's in the lab upstairs from mine at Stanford. And he has this idea, it's just an idea, that because we are indeed more bacteria than we are cells, the question is who's the host and who's the passenger? Like maybe we are just, maybe they're exploiting us to take them around and interact because they interact and grow on one another. And so this idea, this freaks people out. Lex Friedman will love this, that maybe human beings are just actually the vehicles for the microbiome and not the other way around. Anyway, kind of a scary thought. Do you do anything specifically to support your gut microbiome? Are you a probiotic guy or a fermented foods guy or a fiber guy?
So again, I'm going to kind of go straight down the line from what I've heard from Suzanne and other experts. So if you want to improve gut health, one of the biggest levers, the three biggest levers you can pull is not eating too many calories, exercising. There is a connection between exercise in the gut and fiber. So it is, of the things we know, dietary fiber seems to positively impact the gut because it is what's called a prebiotic. So your gut microbiota can take, especially soluble fiber, although there's actually some evidence, at least in mice, that it might be able to use some insoluble fiber as well. I think Suzanne was doing a study looking at hemicellulose and actually seeing that some specific forms of microbiota flourish with hemicellulose, suggesting that they may actually be getting some kind of fuel out of it, which is really interesting. Oh my god.
head, that in his brain was the power to facilitate one move that would contort his entire world forever. And yet, he couldn't even know which choice was right. He thought about how insane this was, to be given the ability to make decisions, but not given the ability to ever know the consequences of them. He felt like he was blind and being forced to drive a car. He wished he could just know how both options would play out. Then he would know which one to choose. Overwhelmed, Carl looked out at the stars and moon glimmering against the water. He closed his eyes and took a deep breath. Suddenly, an older man walked past Carl and sat on a bench.
Especially soluble
Trippy
fiber.
troppa.
Although
Sorry,
there's
sorry.
actually some evidence, at least in mice, that it might be able to use some insoluble fiber as well. I think Suzanne was doing a study looking at hemicellulose and actually seeing that some like specific forms of microbiota flourish with hemicellulose, suggesting that they may actually be getting some kind of fuel out of it, which is really interesting. But again, in mice, so just huge caveat. So your gut microbiome can produce these short chain fatty acids from by fermenting this soluble fiber, and there's quite a bit of evidence that these volatile fatty acids, which can be then actually reabsorbed in through the liver, that they have some positive effects. Like for example, butyrate, when they've done butyrate supplementation, they've actually seen positive effects on insulin sensitivity. So what we seem to understand is that more diversity seems to be better. Fiber seems to be positive. Prebiotics seem to work much better than probiotics.
Supplemented prebiotics.
Yes.
Yeah.
So the problem with most of the probiotics is they're typically not concentrated enough to actually colonize. And even if you do colonize, what happens is, like, let's say you colonize some microbiota that you didn't really have much of. If you're not fueling it with the appropriate fiber, it's not going to stay anyway because it's essentially going to starve. So the research seems to really clearly suggest that eating enough fiber, which is again a prebiotic, that is a better way to get a healthier gut per se than probiotic.
What fiber sources do you use? And I think I realize there's a huge array of choices out there, but people will want to have some ideas as to how they could perhaps mimic what you're doing.
Yeah, and I would just say diversity, right? So there's various evidence from various different fiber sources, fruits and vegetables, obviously, grains, some whole grains, some cereals, and then various other sources. So this is one of the things where we don't really have a good idea if this one source of fiber is better than another source of fiber. We just know that fiber overall is pretty good. And one thing I'll tell people is, like, if you want a longevity hack, I mean, fiber is kind of the longevity hack. If you look at some of these cohort studies, there was actually a recent really large meta-analysis of over a million subjects. And basically what it showed was that for every 10-gram increase in fiber, there was a 10% reduction in the risk of mortality. And that extended specifically also to cardiovascular disease and cancer. So one of the things I'll tell people when they get like really into, whether it's intermittent fasting or, all these other things, say, that's great. Are you eating like over 50, 60 grams of fiber a day?
And just because it's
Oh God.
That's great. That's great. Are you eating like over 50, 60 grams of fiber a day?
And I just because it's conceptualized 50 to 60 grams. So if I were to eat like
Every 10 grams, we just know that fiber overall is pretty good. And one thing I'll tell people is like, if you want a longevity hack, I mean, fiber is kind of the longevity hack. If you look at some of these cohort studies, there was actually a recent, really large meta-analysis of over a million subjects. And basically what it showed was that for every 10-gram increase in fiber, there was a 10% reduction in the risk of mortality. And that extended specifically also to cardiovascular disease and cancer. So one of the things I'll tell people when they get like really into, whether it's intermittent fasting or, all these other things, say, that's great. That's great. Are you eating like over 50, 60 grams of fiber a day?
and I just because it's conceptualized 50 to 60 grams. So if I were to eat like a bowl, let's just say a quarter plate of broccoli, and the broccoli isn't stacked to the ceiling. The broccoli is just reasonably stacked on there. Approximately how many grams of fiber is that? If it's like 2 cups of broccoli, which is a lot.
Yeah, so if you're like 200 grams of broccoli per se would probably be like 5-6 grams of fiber.
And I need to get how much per day?
Well,
Ideally.
I would say typically what the recommended dose is 15 grams per 1,000 calories intake. Because
Okay.
if you're eating, low calories, it's difficult to get enough fiber in. But based on, and again, these are cohort studies, but you can't do 20-year-long randomized human control trials, unfortunately. There doesn't really appear to be a top end, at least for the benefits of fiber. It probably boils down to like how much you can tolerate without feeling uncomfortable, right? Because if you're eating like a ton of fiber, I mean, at some point, it's not going to be very comfortable.
Yeah, exercise becomes uncomfortable
And-
or hazardous. Yeah.
And actually, kind of touching on that because I think it is important. A lot of people have kind of, in the carnivore community, said, well, you don't need fiber. You poop just fine without it. And I always say, well, pooping is the last reason to have fiber. Like, yes, it does help. It does seem to make elimination easier. You can, do it more frequently, adds bulk to stool. But that's not why you should eat fiber. Why you should eat fiber is because of the effects on mortality. And some of the pushback will be, well, this is healthy user bias. And what I'll say is,
Meaning healthy people do this and therefore it's working.
healthy people eat more fiber and therefore,
Okay, yeah.
and I mean, yeah, there's something to that. But if it was just healthy user bias, typically you would see some disagreement between the studies. And a great example of that is like red meat. So not every study shows red meat has an association with cancer and mortality. There's differences depending on the population used, depending on like what they define as high red meat, low red meat, whether it's processed, unprocessed. But I have not found a study on fiber and cardiovascular disease and cancer and mortality where it did not show improvements from higher fiber. So to me, that suggests that effect is real. And so again, as much fiber as you can get in comfortably, I would try to do it because it seems to have some really powerful effects and is good for the gut microbiome. The other thing that may be a consideration for the microbiome is there's some evidence that saturated fat may not be great for the microbiome, that it reduces the prevalence of some of the more positive strains of bacteria. And that appears to be not so much from the saturated fat itself, but from the bile end products that combine with saturated fat, seems to have a negative effect on some of these more healthier forms of gut microbiota. But again, this is really difficult because we don't even know necessarily yet which species of gut microbiota are positive or negative. And this gets into some of these studies where they may call it dysbiosis. Sounds scary, but dysbiosis just means that the gut changed. Right. It doesn't necessarily, it doesn't tell you anything qualitative about whether the change was bad or good. And so these are just things I think we need to keep in mind when we talk about this stuff, that this stuff is still very much in its infancy. But in terms of the big levers, it pretty much fits with what we know about a healthy lifestyle. Exercise, don't eat too much, consume a good amount of fiber from diverse sources.
Fantastic. Fantastic because it fits with what I like to think of as kind of the center of mass of evidence, right? And I'm starting to get some window into what your process is around selection of studies and no one study being holy. But when you look at, as you mentioned, all the studies on fiber having a positive effect to some degree or another, it's pretty hard to refute that there isn't something really interesting there.
And one thing I'll tell people is like, you know, one study, I mean, sometimes I'll change my opinion based on a single study when it's really well done and very powerful. But usually like one study is just going to move me just a little bit, right? And then maybe if another one comes out, move me a little bit more, right? And then like very slowly, I'm going to get some, I mean, my experience with LDL cholesterol, this is something I changed my mind on a while back. When I was younger, like circa 2005, getting into grad school, kind of the prevailing thought was, well, it's not so much the LDL, it's the ratio of LDL to HDL that's what matters. And probably about 5 years ago, and I was pretty strong about that opinion. And then 5 years ago, looking at these Mendelian randomization studies, I kind of went, I can't hold this position anymore.
What is your revised position on LDL?
So if you look at the research, HDL is important because it's a marker of metabolic health. If you have high HDL, it suggests that you are metabolically quite healthy. You very rarely will you have high HDL and like high CRP, which is an inflammatory marker, or dysregulated blood glucose. Almost exclusively people who have high HDL will have good biomarkers of metabolic health. But if you take drugs that raise HDL, it doesn't reduce your risk of cardiovascular disease. In Mendelian randomization studies, which Mendelian randomization basically uses natural randomization. So some people are, in the case of HDL, naturally higher secretors or naturally lower secretors of HDL. And, you know, we talked about how you can't really do a 20-year human randomized control trial. And when you're trying to examine something like heart disease, I mean, that is a lifetime exposure issue. It's very unlikely that you're going to pick out differences between treatments in 2 years or even 5 years. I mean, people typically don't develop heart disease until they're in their 50s, 60s, and 70s. What Mendelian randomization allows is to say, okay, we have these people who naturally secrete more or less, so we can stratify those and look at what is their risk. So if you look at people who are low secretors of HDL versus high secretors of HDL, with holding some of the other key variables consistent like LDL, you don't see an effect on heart disease really.
Of LDL.
Of HDL.
Got it. Okay.
But when you look at LDL and you look at the lifetime exposure to LDL, it is like a linear effect on heart disease. And we know that it's actually not so much LDL, but it's more apolipoprotein B, but that tends to track with LDL just in general. And if you look at the mechanism, I mean, we know that LDL can penetrate the endothelium. So there's the mechanism is present. If we look at the epidemiology, it supports that it's an independent risk factor. And then again, these Mendelian randomization studies where we can kind of look at people's exposure over a lifetime, and then we see that linear kind of dose-dependent effect. To me, that was convincing enough to change my mind on that particular topic. And then if you look at like some of the Framingham data, look at if you like stratify like high HDL versus low HDL, both groups looking at high LDL and low LDL. So if you have high HDL, low LDL, you will still be lower risk factor than somebody who has high HDL and high LDL, right?
So the ratio does matter.
So the ratio does matter. Same thing with inflammation. If you look at people who are low inflammation, low LDL, they'll have a lower risk than people who are low inflammation, high LDL. So again, that was kind of sufficient for me to change my mind. But it was like not just one study came out. It was, okay, then there was another study, and then another study, and then another study. And at a certain point, I go, okay, well, now I either have to change my mind or I'm basically just going to be cognitively dissonant and say, nope, I don't believe all that, And so I think that's one of the things to keep in mind. People will say, oh, you're saying this is a bad study. Very rarely will I call something a bad study because data is just data. But the issue becomes how it is presented and how broadly it's applied in the mainstream media or by people on fitness influencers. And what I'll do is try to step in and say, okay, let's consider X, Y, and Z as well. And then it's not a bad study, but let's just be careful about how broadly we apply the interpretation.
Yeah, well, and I think you're in a very unique and important position to be able to place things into their proper context because of this, for lack of a better word, holistic view of how the psychology, placebo effects, also core physiology relate to one another, and so on. In fact, I think that your training as a biochemist and then training as in nutrition with somebody who, Don Layman, who was pushing you to focus on outcomes, I think that's a beautiful capture of the continuum at which one can look at something. Because for those of you that don't know out there, a lot of laboratory studies on mice and humans, for instance, in the realm of biochemistry or in vitro studies, you'll see a change in some molecule can be quite dramatic. And then the assumption is, oh, you take the drug that will change that molecule in a particular direction, and then you'll get the effect you want at the whole organism level. The person will lose weight. The person will gain muscle. The animal will not have Alzheimer's, et cetera. But it just doesn't work that way because of the redundancy and this interplay.
Well, a great example of that is, so my research was actually in rodents. All my studies on protein metabolism and leucine in particular is what we were studying. Well, we know if you give leucine, it increases muscle protein synthesis. But we also know if you supplement with leucine, people don't get more muscular.
I was about to say, so all you have to do is supplement with leucine?
Right. And so how is that possible? Where, muscle building is not just protein synthesis. It's also the balance between synthesis and degradation. So, and degradation just happens to be very, very difficult to measure. But a great example, and again, one of the cool things about my PhD was actually change the way I ate, which I think is interesting. So before I had been like, I eat 8 meals a day, eat every 2 hours, try to keep
meals a day.
Yeah, when I got to grad school. In order
to hit that 30 grams of protein per meal.
Get that amino drip going in was the idea, right? Like just have an IV hooked up with amino acids.
Not really, folks.
Not really, yeah. But that was kind of the concept. But the first study I did, we basically looked at, okay, a lot of people had measured the amplitude of protein synthesis in response to a meal. We wanted to see how long does this last and where does it peak, right? And so my thought was, okay, well, it'll probably track with plasma leucine. You give, for those that are not familiar, leucine is the amino acid that is almost exclusively responsible for increasing muscle protein synthesis when you eat protein. So it's one of the branched chain amino acids. So we wanted to see, okay, how long does this effect last? So we fed these animals whey protein. And again, I thought, okay, well, however long plasma leucine stays up, that will be how long protein synthesis stays up. And so we got the protein synthesis data back, and it was peaked at 90 minutes, peaked from 45 to 90 minutes, and then was back down to baseline by 180 minutes. And so when I went to do the plasma leucine analysis, my shock was at 3 hours, plasma leucine was still plateaued out. And I said, okay, well, when I look at the initiation factors, that will show me something. So for those not familiar, this is part of the mTOR signaling pathway. So two of the targets of mTOR, when it's stimulated, leucine stimulates mTOR. Two of the targets of mTOR are a protein compound called 4-EBP1, and then another one is called ribosomal protein S6K. So I don't want to get into the specifics about it because it's kind of beyond the scope, but basically when these things are phosphorylated by mTOR, it increases the rate of translation initiation, which translation initiation is basically the process of the ribosome hooking on to the mRNA and then starting protein synthesis. So I was looking at the phosphorylation of 4-EBP1 and RPS6. I was like, okay, well, I'll probably see these things come down at 3 hours. Still plateaued. And so then it was like, what's going on here? So I actually kept rerunning the data and rerunning the data and rerunning the data. And I'll never forget, I went into Layman's office, and this is like, 6 months after we've done this study, because this analysis takes time. He's like, so where are we with this duration study? I said, well, I just got to run the plasma data again because it's not right. And he's like, well, why is it not right? And I said, well, it just doesn't make any sense, And I kind of went through, he's like, well, describe to me your technique. Like, how are you doing this? And I described it. He said, well, how's your standard error? And I told him what the numbers were. He said, it sounds like it's good data. He said, it sounds like you are trying to get the data to fit your conclusion, and you need to change your conclusion to fit the data. And that statement.
This is why we do PhDs.
This
right?
Is why, yeah.
You need an advisor.
This is why I'm so skeptical of everything, because I have had so many of my ideas crushed by my own data, right? So we actually ended up, this this kind of effect, this phenomenon is called muscle protein synthetic refractory period. So basically, like once you trigger the system, kind of runs for a defined period of time, and then it takes time to essentially like reset, for lack of a better term. It's also been referred to as the muscle full effect. But so I looked at that and said, why am I eating every 2 hours then? You know, and there was even a study out of Wolf's lab, like back in '99, I think, where they infused essential amino acids for 6 hours. Protein synthesis went up, peaked at 60 minutes, came back down at 120, and never went back up again.
Maybe I'm being naive, but I would have thought that if protein synthesis goes up and then comes back down, that eating more often would be exactly the thing you would want to do if your goal was to get increased protein synthesis, because you'd be pinging the system periodically.
But the problem is the plasma amino acids are still elevated
So it's essentially like eating the whole way through,
Right.
from the perspective of leucine.
from the cells.
Got
Yeah.
it.
So that was one of those things where I said, you know what, I'm actually going to eat less often, because like if I'm eating and 3 hours later, I've still got, capped out plasma amino acids, and we looked at all kinds of stuff. Like we looked at intracellular leucine just to make sure that, that wasn't falling off. It wasn't. We looked at all the plasma essential amino acids because we were thinking, well, maybe protein synthesis is, sucking some of these amino acids out of the plasma and they're dropping, and that's causing it to kind of short circuit the system. That wasn't the case. It just essentially what the evidence suggests, and I think we're the only ones to show this so far. So I'm not ready to say that this is a real effect, because I hold out the idea that data artifacts do exist and you can't be totally sure. But we saw an increase in AMP kinase kind of around this mark where protein synthesis started falling off. And we also saw a decrease in intracellular ATP. And protein synthesis is an ATP dependent process. And so what we think might be happening is you're, consuming protein and you're increasing muscle protein synthesis. And then at a certain point, it's has enough effect on your, energy metabolism in your cells that it kind of not short circuits it, but it kind of cuts it off, right? So again, we're the only ones to show that I'm aware of. So, and that was again in rats. So I always talk about data. Like there's data I'm willing to bet my toe on, my foot on, my leg on, and my life on. I'd probably barely bet the end of my little toe on that one. I'm not quite sure, but it's interesting nonetheless. So
A proportional wager.
that's a great example of, okay, we're looking at this mechanism of mTOR signaling. And if we just looked at that, we'd say, oh, well, protein synthesis is going to stay elevated for, past 3 hours. But that's not what we saw. So, yeah, I think it's, again, that's why I really try to, get people to say, well, mechanisms are important. And especially if you're seeing an outcome, it's important to identify mechanisms that may explain that. But let's step back from the mechanisms, from trying to chase mechanisms, and let's look at like chasing outcomes in terms of what we recommend to people.
Excellent point. In terms of chasing outcomes, a number of people I know are interested in weight loss or weight maintenance. And several times throughout today's conversation, we've come back to this issue of satiety signals, whether or not they're brain-based, body-based, or both. Not wanting to eat more is a great way to maintain or lose weight because you simply don't want to. I heard you mention earlier that protein, and maybe specific types of protein or sources of protein, may provide better satiety signals than other macronutrients. Could you briefly talk about how macronutrients, including protein, but also carbohydrates and fats, impact satiety? And from the standpoint of somebody who, for instance, would like to, quote unquote, lose a few pounds, right? Probably would be happy to gain a little bit of lean body mass, provided it was in a particular location on their body. That seems to be a thing now, directed hypertrophy, if you will. And how much they should focus on protein as a core component of creating this diet. Assuming everything else is being done correctly, they're going to hit the right number of calories relative to their output, NEAT, et cetera. How should we think about protein and satiety signals? And are animal sources of protein indeed more bioavailable? That's a tricky word. For sake of muscle building, but also for sake of somebody who just would like to lose body fat. They don't want to lose muscle, and they'd like to bring their weight down a few pounds.
So a lot of things
or more.
Yeah, a lot of things to unpack there. Of the macronutrients, protein is definitely the biggest lever that you can pull, because even if, it doesn't take a ton of protein to get a lot of the muscle building benefits. I mean, I think the benefits really start to plateau out around 1.6 grams per kilogram of body weight. There's some evidence that maybe even up to like 2.4 or 2.8 grams per kilo may give like a little bit more benefit. I think it probably looks something like an asymptote in terms of a curve, where as you put more into the system, you always get a little bit more, but it just gets to the point where it's so infinitesimally small benefit that it's, for all intensive purposes, no benefit.
But you mentioned 1.6 grams of protein per kilogram of body weight. Would you consider that a threshold that most people should try and achieve daily?
I think I see very few downsides to hitting that. I mean, I know some people, and this is going to get into a separate conversation, but I know some people will say, well, I don't want to stimulate mTOR because that's going to make me die early. And I think one of the things to keep in mind is, if you look at, there's kind of this thought process out there that if you're stimulating mTOR, that protein is going to make you die early. And first off, we have very little human outcome data to support that claim. And the second thing is, if you look at any macronutrient isolation, I can make a mechanistic argument that it's going to kill you. So fat, if you take in fat, it decreases flow-mediated dilation. Flow-mediated dilation is important for heart health in the short term. Carbohydrates stimulate insulin. Insulin, pro-inflammatory, and all these other things. And so I can make an argument for any single macronutrient to be negative for longevity. I really want people, this is something that even scientists get wrong. They look at an acute response of something and assume that that is going to relate to long-term outcomes and signaling. So let's just take exercise, for example. If you didn't know anything about exercise and I said to you, Andrew, I'm going to do something that's going to make your heart rate go up, your blood pressure go up, your inflammatory markers go up, your reactive oxygen species increase, you're going to say, and it's going to damage your muscles, you're going to say, I'm not doing that. That sounds horrible, but it does all those things in the short term. But what is the long-term effect of exercise? You actually get healthier. All those things improve. Now, I'm not saying that, protein is a longevity hack or anything like that, but what I'm saying is, I think some of the arguments out there based on mechanistic, this increases mTOR, therefore we don't want to do it, I think it is a much more complicated argument than just that. So there's that. So protein is the biggest lever. I would shoot for 1.6, grams per kilogram. If you can do more, great. There doesn't seem to be really downsides to it, even like up to very high levels of protein. Jose Antonio did a study that was a year-long randomized control trial. And again, it's just 1 year, but they were looking at all sorts of different biomarkers. And basically, even up to like 4 grams per kilogram of protein, they couldn't really find any negative health outcomes from it. Other than people were just so satiated, they ended up eating less calories. So protein is a big lever because, one, it has a higher thermic effect of food. So you're getting a little bit more calorie burn per day, even though it's not a ton because TEF is a pretty small percentage of your overall energy expenditure, but still a benefit. You're getting the effects on lean body mass. If you're in a diet, it's going to help preserve lean body mass. If you're at maintenance, it's going to help build or preserve lean body mass. And if you're in a surplus, it's going to help build or preserve lean body mass. Then you get the effects on appetite. So now I want to be careful because appetite effects tend to be very specific to individual foods, right? So you can take a high protein food and make it not very satiating. So take, for example, like a really tasty protein bar, which, back when we were getting into this, no such thing existed. Now you have protein bars that actually take pretty darn good. But if you eat one of them, I mean, are you really satiated? I don't really feel satiated after a protein bar.
That's my pre-meal snack.
Right. So why? Because, I mean, it's processed, refined, and made to be very palatable, okay? But take something like a 200-gram chicken breast, very satiating, right? And that's why when people say, well, carbohydrates aren't very satiating, it depends on the carbohydrate. I mean, when you look at the satiety index, a plain baked potato is about as satiating as it gets.
Yeah, if I eat a bowl of oatmeal,
Mhm.
I feel pretty good afterward.
Yeah,
for a while, right? I mean, I'll eat that along with some other things, but
Yeah.
I completely agree. So you're saying that the form that it comes in, maybe even how much chewing is required, how good it smells, that
It
your
all
psychological
matters.
associations. Because to me, a steak is an incredible meal. Like,
Right.
I mean, if I had to pick one food that I could eat, even though I'm not pure carnivore, for the rest of my life, it would be that, because I think it would get me where I need to go. And then I'd probably have to sneak some fiber,
Yeah.
you know, but it's an excellent point. I have a question that I don't want to take us off track, but I'm hoping it relates enough that you could answer it now. In the context of this, if I'm going to eat, let's say 2 grams per kilogram of body weight protein, and I'm not eating multiple meals, maybe I'm eating 2 or 3 meals per day, I'm certainly going to be eating more than the 30-gram threshold that was thrown around for a long time, that we can only assimilate 30 grams of protein per meal. Should I just not worry about that? Some of it is going to go towards the thermic effect of food. Some of that might be converted into glucose, of all things, through gluconeogenesis. So should I worry about this 30-gram cutoff? Because I think balancing the 1.6 gram per kilogram body weight threshold with number of meals, with the need to exercise and work and live my life and sleep, et cetera, pretty soon you run into bottlenecks
Yeah.
where you just can't do it all,
Yeah.
or you're spending so much time trying to focus on
You
it
can't
all.
optimize all the things at the same
Right.
time.
You lose your mind and your body. So what is necessary in terms of frequency in if one is getting enough protein? And then tied into that question, is there any reality to this idea that if you eat 1 meal per day, or you're fasting, and then you eat, let's say 200 grams of protein in a single feeding, that you can assimilate more because you were sort of protein starved? Is that a real thing?
So most of the studies with protein are after a fast, because to assess it with stable isotope, you have to be in a steady state. So we haven't observed that. It doesn't appear that fasting really kind of allows you to assimilate more protein after a fast. So this gets into a core of one of the things I looked at in my PhD, which is, does protein distribution matter? Because most Americans get about 65 to 70% of their protein at dinner, right? Breakfast tends to be pretty minimal protein foods.
Do any cultures actually eat a big breakfast and not a big lunch and dinner? I get,
So-
we all
some-
heard that was ideal. We'll get into circadian timing in a little bit,
Yeah.
but does anyone actually do that? Steak and eggs for breakfast and then taper off the rest of the day?
I know German culture tends to have a big breakfast, but it also tends to be like sugary foods and whatnot. As far as like teleologically, I'm actually not sure about that. So if you look at that, and then you consider that protein doesn't really have a storage mechanism, right? Like people will say, well, lean tissue is a storage mechanism. That's like saying a house is a storage facility for wood. If the house is made out of wood, you could get wood out of it, but that's not why you build the house, right? Like you're building the house out of a demand. Same thing for muscle tissue. There is a free pool of amino acids, but it's very, very small. So when you consider things like fat, which basically has unlimited storage capacity, carbohydrate, a relatively large storage capacity, you can store 400 or 500 grams of carbohydrate between your liver and muscles, and then protein, which almost has no storage capacity. The idea that, you could make up for low protein at one meal by over-consuming at another meal didn't make sense to me. So one of the studies we did, and again, in rats, we took both groups were getting whey protein, so high-quality protein. They were getting the exact same amount of calories, exact same amount of, nitrogen, exact same macros. Everything was the same. The only difference was one group basically got kind of 3 meals of similar amounts of protein. Like dinner was a little bit bigger because we wanted to keep it somewhat similar to how people eat. But each meal was going to be over the threshold to stimulate muscle protein synthesis. Whereas the other group, I constructed it so the first 2 meals of the day should not stimulate muscle protein synthesis. It should be under that threshold. And then the last meal was about 70% of their total daily protein. And so we had them eat those for 11 weeks. And I'll never forget this. This is how obsessive I became about it. Is there was 110 animals in this study, and I made all the diets, and I weighed out exactly every single meal for every single animal for 11 weeks. So I was in there at 6 a.m., I was in there at noon, and I was in there at 6 p.m.
I love it. That's
So-
a kind of PhD student that professors dream of. You must have been a dream student.
So at the end of 11 weeks, we looked at lean body mass, we looked at body fat, we looked at hind limb weights. We didn't really see differences in lean body mass, but what we did see was a difference in hind limb weights. It wasn't massive, but there was a significant difference in the size of the muscles of the hind limbs of these animals. And so it's interesting that there wasn't a difference in lean body mass. And what we found, at least with the liver, the animals that were eating the like one meal with really high protein actually had bigger livers. Not like a huge amount and not something that I would consider unsafe, but it was a statistically significant difference. And so to me, at least, like if I'm trying to explain like no difference in lean body mass, but a difference in these hind limb weights, maybe there's some like sequestering of, like that's fueling a little bit more protein synthesis of the splanchnic tissues rather than, because you're capping out skeletal muscle protein synthesis. And we do know that the splanchnic tissues are more sensitive or have a greater rate of protein synthesis per day. Like the rate of skeletal muscle protein synthesis in humans is about like 1% per day. So it takes like 100 days to turn over, skeletal muscle. Whereas like your entire gut, your entire GI will turn itself over in like 2 to 3 days, right? So really, and the liver also has a very high amount of protein synthesis, which is one of the reasons it's actually one of the most metabolically active organs. So all that to say, there's been one human study that showed something similar, and then there's been a couple others that didn't. And then in the intermittent fasting studies, which is maybe a good tool to look at compared to continuous feeding, one thing I will say is it looks like the 16-8 intermittent fasting style. There's been a couple studies with Grant Tinsley, and this is something I've changed my mind on as well. Grant Tinsley has done a couple studies where they used the 16-8 protocol. They had them train during their feeding window, and they had them eat, I think it was at least 3 protein-containing meals during that 8 hours.
These are humans?
These are humans. Mm-hmm. And they saw no difference in lean body mass at the end of the study compared to people who were eating, as many times as they wanted throughout the day. Now, if you look at some of the more extreme forms of fasting, like alternate day fasting or like 22-2 or 24, there are some studies where you do start to see differences in lean body mass. So my suspicion is, and I'm just guessing, so this is tenuous. My suspicion is probably if you're getting like 2 to 3 like high quality protein meals in a day, you're getting the vast majority of the benefits of protein. The most important thing is getting enough total. And then secondarily, trying to get, at least 2 or 3 meals with high quality protein in. But if you're going like pretty extreme with like alternate day fasting or, maybe only 1 meal a day, then I think there may be some effects on lean body mass. But again, these can be mitigated as well if you're doing, hard resistance training. Typically, that is the biggest lever in terms of lean body mass. Yes, protein distribution may make a difference, but I'm trying to put it in context so people don't feel like they need to go out and eat, 4 meals a day. But again, so what I would say is like some of the more milder forms of, time restricted eating appear to be fine for lean body mass. Now, the caveat is the following. One of the nice things about animal studies is when you consider if you want to have a high subject number, high level of control, and a long duration, it's pretty much your only option, right? So I've in our research review reps, I created a Venn diagram, which basically is like 3, circles crossing over. One is study duration, one is level of control, and the other one is subject number. And to get all 3 of those circles to cross over, it almost has to be in animals.
Right.
So
and reps, it's a newsletter or a book?
So it's our monthly research review.
Great.
So every month we review like 5 studies that come out in fitness and nutrition. Like we'll usually do at least 1 nutrition, 1 training, and 1 supplement per month.
We will put a link to where people can sign up. This is a sign up format. Great.
Yep. So it's a subscription-based service. So basically, when people might look at like my study, well, why did you see a difference in muscle weights, whereas some of these other studies don't see a difference? I weighed out every single meal for 11 weeks. And keep in mind that 11 weeks in a rodent's lifespan is a really long time. That's about 1/8 of their total lifespan. So is it that there's no effect, Or is it that the effect is relatively small and would take a really long time and very high level of control to see in humans? I don't know, but I think what I would say relatively confidently is if you're going to do like a 16-8 intermittent fasting, you're probably fine, especially, and again, what is the goal, right? Like if you're a bodybuilder looking to be the most massive person you possibly can, or you're a football player, or you're in some field that having as much lean body mass as possible is really important for you, then I would say, well, you're not really gaining a whole lot by doing some form of time restricted eating.
I think most of the people listening to this do not fall into that category.
Right.
I think most people want to maintain or lose weight. They'd like to perhaps add a bit of quote unquote shape or muscle to specific areas of their body and lose body fat.
Right. And I think your normal forms of time restricted eating are probably perfectly fine for that. Right. And again, if I don't want somebody to think, well, I do, alternate day fasting, there's no point to me resistance training because I'm going to lose muscle mass. No. You can still build muscle doing that. You just might not build as much muscle as you would if you were eating in a more traditional format. But if that's something that works for you and your goals, and especially if it's fat loss or controlling your calories, then again, it's about the hierarchy of what's important, right? So to answer your question, I do think that timing and frequency matters a little, not so much frequency, but distribution more so. So I think the distribution matters, but it's a much smaller lever than just getting enough total protein in. And then as far as like animal versus plant, I used to be in the camp of there's no way somebody can build as much muscle on a plant-based diet. And now I think I've come back to you can, it just requires a little bit more planning. And I don't want to say always, but it's very difficult to do without an isolated source of protein. So unless you're going to supplement with an isolated plant source of protein, it's very difficult to get enough without going over on total calories, because you can figure that, especially like take somebody who may be calorically restricted, trying to get enough protein from whole intact plant sources. So you've got a few different things working against you. One, the sources of protein you're consuming also have carbohydrate and or fat. Two, it's a less bioavailable form of protein. And three, it's a lower quality of protein in terms of it has typically less leucine, less branched amino acids, and less essential amino acids.
You answered the question that I almost interrupted you to ask, which was, does it boil down to the leucine content? And it sounds like that is one of the components, and that a lot of the vegan and vegetarian sources of excellent protein, that excellent protein vegetarian or vegan source is co-packaged with calories from carbohydrates and or fat that make it hard to stay under the caloric threshold. Whereas a steak is, I'm not, and obviously people might want to avoid that for ethical reasons,
sure,
but that's a different matter entirely. But a steak or a piece of chicken or an egg is, well, an egg, has a yolk, which is, there's fat there, but is almost a pure protein fat source. There's no carbohydrate along for the ride.
Right. So I think what I would say is that, you can do it. Takes a little more planning. And you're almost always, if you're a vegan, especially, you're going to be better off like supplementing with some isolated form of protein, or vegan form of protein. Now, this is where it gets into, people say, well, what about the limiting amino acids and those sorts of things? It's a consideration. Some of the better forms of vegan protein in terms of amino acid content are like soy. Now, I hear everybody screaming online about their testosterone levels. In terms of actual outcomes and looking at testosterone, there was a recent meta-analysis looking at soy. And I think if it's your only source of protein, then maybe the dosage is high enough to cause some weird effects. But if you're just using it like once or twice a day, it doesn't seem to have an effect on testosterone or estrogen. So that can be a decent source of protein because it is a complete protein source. It does have a PDCAAS of 1, which PDCAAS is basically a measure of protein quality based on, does it provide enough of all the amino acids so that none are limiting. And so soy is one of the only vegan sources that does that. Interestingly, potato protein isolate actually has a similar essential amino acid content to whey. So isolated potato protein, it's just really hard to find. I've been trying to source it.
But vegans take note, vegetarians take note or vegans rather, because whey is vegetarian. And whey is a very high quality protein source.
Very high quality protein source. And actually, they're actually creating whey now out of, I think it's, I may mischaracterize this, but I believe they're able to produce it out of like yeast or something like that.
Amazing.
That so for vegans now this is a great option because you can have whey that's not animal based that is going to be every bit as good as an animal based whey. So I think that's great. Getting to the leucine, let me go back. Sorry. So another reason that using an isolated protein can be helpful is because it's more bioavailable as well when it's been isolated out. When it's the protein bound up in the actual plant material, it tends to be less bioavailable. Now, cooking can help increase the bioavailability because it breaks some of those bonds and whatnot, but it still seems to be lower. And it's really interesting. There was a recent study where they did a corn, wheat, and pea blend of protein versus whey. And basically the outcome was 30 grams of each stimulated protein synthesis to a similar degree. But the plasma amino acids in the plant-based protein still did not get as high as with whey. Now, it may be that it doesn't matter because once you get to a certain level, you get all the benefits. So, but I still found it interesting nonetheless that they didn't quite get as high. The other thing to consider with the vegan sources of protein is the leucine content. So one of the studies we did was we looked at wheat, soy, egg, and whey. Isonitrogenous, meaning we equated protein between the groups. Isocaloric, we equated calories. And we looked at muscle protein synthesis. And I think the meals were 15% of total energy from protein. So like your food guide pyramid level of protein. And we saw that in the wheat and soy group, they did not increase muscle protein synthesis, but the egg and whey group increased muscle protein synthesis. Now, what's really interesting is we went back and we took wheat and added free leucine to it to match the leucine content of whey, and the protein synthetic response was identical. So again, I don't like to simplify things too much, but leucine appears to really be driving this ship. And I'll never forget, Layman called me into his office one day, and he would always do these like thought experiments of, he liked to think about why something occurs the way it does.
Dangerous territory.
Yeah, so he would say, one day, I'll never forget, he's like, Lane, why do you think the body evolved to just sense leucine for muscle protein synthesis? And of course, I'm like, I don't know, man. I just work here. Like, I'm just trying to get my PhD. And he said, well, think about it. You would want something that really wasn't extensively metabolized by the gut and liver because you would want it to show up in the blood in values that reflect what you just ate. Makes sense. And you would want it to have passive diffusion across the muscle cell because you want it to be concentration dependent, which it is. So
get into the tissues and cells that need it most.
Right. So, not having active transport, but rather passive transport. So yeah, I thought that was really interesting the way he broke that down. So few different options for the vegan folks out there. You can use an isolated source of protein. And again, like there's going to be good options coming because this plant-based whey is going to be a great option for folks. You can add free leucine to it, to whatever your source of protein is.
Just buy supplemented leucine
Just buy
powder.
leucine. Now, it tastes horrible.
Yeah, I think I've heard that. Maybe I've even tried it.
It's completely nonpolar, does not dissolve in anything,
Can
and
it be
it
put
is
into capsules?
gross. It can be put into capsules, yeah. So you could take a capsule, like for example, if you're eating your normal meal, you could just take a capsule of like 1 gram of leucine. It's probably going to bump you up enough that you're going to be good to go. And then there's options like blends, especially with corn. Corn is actually very high in leucine as a percentage of its protein. Now you got to remember, like you go eat corn on a cob and you're getting like 2 grams of total protein, so it's not that much leucine. But if you isolate out the protein, put it into a powder, well now, when you're getting like 80-90% of the weight is now protein, corn is actually about 12% leucine in terms of the protein. So a great source of leucine.
I'm actually not listening right now, so I'm just gonna go switch back to Spotify. I don't know if you can hear this, but who knows?
don't fight for my respect, bitch, I fight for D. Off the street. Baby girl, I'm finna rock your shit.
Sticky situation, discombobulation. Caught me red-handed, palms itching like rosacea. Standing like ovation on business occupation. Dripping condensation, got a whisper conversations. So,
Grab that mop, grab that mop. I got something big.
Better find a mop, it's getting sticky in this bitch. Better find a mop, it's getting sticky.
Yo! Oh shit, where are we? Oh, let's do this. This is split squat. Just one. Hello.
Can you offer a safe and happy home to a child in need? Becoming a foster carer means opening your heart and your home to vulnerable children. Becoming a foster carer with Uniting means you'll never have to do it alone. Uniting will guide you every step of the way with training, tax-free payments, respite breaks and 24/7 support. Give a child the love and stability they deserve. Visit our website to find out how at unitingvictas.org.au/fostercare.
Don't let back pain take over your day. Try Panadol Extra. Extra strength pain relief that provides greater relief than standard paracetamol tablets.
Why is it
So
7?
whether you're powering through the workday or finally putting your feet up, choose
split
Panadol
squat.
Extra for
Anyways.
tough pain relief from the brand
Didn't
trusted by
shoulder.
millions of Aussies. Always read the label and follow the directions for use. Incorrect use could be harmful.
Oh, side shrug. Okay, I'm already done. Thank you so much. I'ma go take a bath, bruh. Buy yours. Ice cold bath, by the way.